In this section, we're going to look at other graphs and data plots. Now, you probably won't see these as often as histograms, but they're still really important to be familiar with. So, scatterplot uses to assess relationships between two variables. We're going to be looking at these again later on the semester when we look at correlations. Now, there's two requirements for doing a scatterplot. First of all, the correlation has to be linear. So as we can see in the example on the right, that's a roughly linear correlation between sales and temperature. So as the temperature is going up, there are more sales. The data points often have to be relatively close to the apparent line. So again, if we look at this example, we can see that if we drew a line up through here, these data points would be relatively close to it. That means that that line is a good predictor for where the data is going to be. So remember, with statistics, what we want to be able to do is make accurate predictions from our data. So we need to also think about what it means if we see two clusters of data. So your book talks about this a little bit and gives a good example. So when you're go ahead and read through that example and then come back and let's talk about that for just a few minutes. So the example in your book is talking about looking at production of pennies. However, it taps in the basic idea that if you're seeing two clusters of data separated, often separated by a gap especially, then this suggests that you're actually looking at two different populations. So this is really important when we're looking again at making an accurate prediction. Perhaps if there's some really important differences between your two groups, drawing a correlation line through them, it may not actually give you an accurate prediction for either of them. So you may want to be able to work with the two separate sets of data. We'll look at this a little bit more when we get further into looking at correlations. Okay, so moving on to the next one, we're going to be looking at two other types of data plots here. So one is a dot plot and the other is a stem plot. Now, we don't see these as often as we used to. They're more a product of a time period when we had dot matrix printers. However, if your professor is giving you classical research to look at that goes back, you may actually encounter them. So you do need to be familiar with them so you know how to use them. A dot plot occurs when we graph each data point along a horizontal scale of values. So, and in these cases, the dots representing equal values are stacked. So this would give you a quick visual representation again of the data. The stem plot that we'll come back and look at and again in a moment represents quantitative data by separating into two parts where we have a stem and a leaf. So let's look at each of these when we're looking again at the class pulse rate data. All right, so working through these, here we're looking at the dot plot. So here on the right hand side, you see where I've gotten you started by drawing the horizontal scale values. Now here we're using the class boundaries, so we don't have a gap between them. So looking at this and take a few moments, draw this into your notes to work with this data, and then move on to the next slide where we're going to look at starting to enter the data. Okay, here's the beginning entry of the data. So here you can see where I put the data value 60. It comes after the class boundary of 59.5. And you also see I have 61, 62, 63. Now notice the green arrow pointing to the location of 68. We have two 68 pulse rates in this class data, so you can see they are stacked one on top of the other. This gives you the visual representation. Okay, so pause this video for a moment, go through and finish entering the data into your dot plot, and then move on to the next slide to check it. Okay, here we have our finished dot plot. So yours should look something like this. Now, as you can see, if you look at the old dot matrix printings, you can see that this would be much easier and faster to print out on the old dot matrix than a full printed histogram. I can assure you from having worked with both, trying to print a histogram on old dot matrix printers is going to consume a huge chunk of your time and not give you that much more detailed information than going through and doing this quick dot plot. Once again, you're probably not going to see too many of these, but if you're reading some classical work from your professor for the foundation of a particular area, you may still encounter these, so you need to be able to read them and understand them. All right, now we're going to look at the stem plot. This is a little confusing when you just read it, but it's actually pretty straightforward once you work through the example. So here when we're looking at, we're going to set a stem, which is the value that's to the left-hand side of this dark line. And here we're going to use the leftmost digit. This is pretty common. Okay? And then over to the right, we're going to put, it's going to be the leaf component of it, which is where we put the rightmost digits. So let's take a look at an example of this. Here we've only got two components of the stem, a 6 and a 7. All of our class pulse rate data fall within these two. Next, you can see I've started to add in the rightmost digits from each of the data values. So you can see where I've got 60, that's a 6, and then I put a 0 off to the side. Notice that I have 1, 2, 3. That's because I have a measure of a 60 pulse rate, 61, 62, and 63. So as you're entering in your numbers to the right-hand side for the leaf, they need to also be in numerical order. Notice looking at the next one for the stem of 7, we can see that we have two scores of 70, so I've got 2 zeros before I move on and put in the 1. So pause this video for a moment, go through and finish completing a stem plot version of your own for the class pulse rate data, and then we'll come back and check it together. You should have gotten something that looks just like this. So what we can see when we're looking at this really quickly, actually, is we can already tell that we have a few more class pulse rates data in the range of 60 than in 70, right? And we can also see which are the class pulse rates that are occurring more often than once. So this allows us to look really quickly at it and see, well, 66 occurs 2 times, 70 occurs 2 times, and 72 occurs 2 times. So that's really quick information we can process from something like this. All right, now another thing we're going to look at is charts. Your book gives some good examples of these, so again, I suggest you look at those as we're working through these examples. So the first one we're going to look at is a Pareto chart. This is a bar graph for categorical data, okay? So we'll look at an example of that in just a moment. The bars are arranged in descending order according to frequencies. So this is really important because when we're looking at this, the order starts on the right-hand side for the one that occurs the most often, and then goes down on the left-hand side, and then goes down to the right-hand side. This is different than if you're looking at a pure histogram, so make sure you've got that distinction clearly in your mind. Now, when we're looking at Pareto graph, take a few moments and look at your text and find out what goes along the vertical axis and what would go along the horizontal axis. My vertical scale is going to be frequencies or relative frequencies, depending upon what I'm working with. And the horizontal scale is going to be the different categories of qualitative data. For example, how did you learn about our product? So I would have a category of TV, newspaper, and email. Keep in mind that if most people learned about the product from the newspaper, that would be the one that would occur first on the left-hand side of my Pareto chart. However, if people learned most about it from TV, that one would come first. Because they're qualitative data, there is not any inherent order in which they need to be placed. So a Pareto chart says you always start with the one that has the highest frequencies. Now, the pie chart depicts categorical data as slices in a circle, with each size of the slice being proportional to the frequency count of the category. We're pretty familiar with those. Now, let's do a few moments of critical thinking here. Which type of chart is preferable and why? Take a few moments, pause the video, and look at the material in your text, and then compare the examples there, and think about which one gives you the more specific, precise, and accurate information. The Pareto is going to be the better option. It allows more accurate comparisons due to having an appropriate scale mark. This is going to be really important whenever somebody gives me data in a pie chart and asks me to work with it. I immediately ask them to convert it into a Pareto format. That allows me to look at more subtle differences, and also when we're doing something like this, that's going to be a good sign that you know what you're doing. So when somebody's giving you data in a pie chart, ask it for in a Pareto format before you begin to try to work with it. All right, this concludes our section looking at different charts and graphs. Next up, we're going to have looking at how to work with spot graphs that are deceptive, and then what kind of corrections you need to be looking for on them.